Hey code chasers, how are you? I hope you're fine and healthy. With that healthy vibe, we will start our video today. I am Adilakshmana Tiketi. Welcome to our channel Code Chasers. In earlier video, we saw what is master-slave architecture in HDFS, that is Hadoop Distributed File System. We'll recall some points regarding how master-slave architecture is implemented in HDFS. In master-slave architecture, there will be a master node and a slave node. In HDFS, master node is nothing but a name node and slave node is nothing but a data node. We'll also recollect some points regarding the name node and the data node. Master node, which is a name node in HDFS, and we generally call it as a master daemon, and name node manages all data nodes, and also it regulates the client access to files, and also it executes the read-write operations on files. Coming to slave node, that is data node, we generally call it as a slave daemon. Data node creates blocks as per the instruction from name node. Also, data node stores actual data in blocks. Also, data node performs read-write operations as per client request. One important point to note here is name node executes read-write operations and data nodes performs read-write operations. Now, we'll jump into today's video. In this video, we will see blocks and replication in HDFS, that is Hadoop Distributed File System. Suppose when we have a large file, Hadoop divides the large file into smaller blocks of data and process the file. Okay, as per Hadoop 1.x version, the default block size was 64 MB. But from Hadoop 2.x versions, the default block size was increased to 128 MB. Now, if you have a large file of say 500 MB, considering the default block size of 128 MB, the Hadoop will now divide the large file into 4 blocks. Okay, block A, B, C of 128 MB and block D of rest size, that is 116 MB. And if we combine the data in all these 4 blocks, they'll sum up to 500 MB. When we have a very large file, say in TBs, 1 TB, 2 TB, 10 TB, we can customize the block size as per our requirement in HDFS site.xml. Don't worry if at all you don't have any idea of what is HDFS site.xml. You just remember it as a configuration site file. Okay, we can configure the block size here. In our coming videos, we'll discuss in detail what is this file and about the Hadoop environment. Anyway, in our future videos, we will be going to work on Hadoop environment. So as of now, you just have a look. Like this is the Hadoop environment. Okay, in Hadoop environment, we will be having a file named HDFS site.xml. In that HDFS size.xml, we can see the block size is configured to 128 MB for each block. Okay, if at all we have a very large file and if we want to increase the block size or if we want to decrease the block size, we can decrease it here. We can configure it here. Okay. We have to always make sure the number of blocks should not be very high. At the same point of time, the number of blocks should not be very less. There should be always an optimized number of blocks for the data to run smoothly without any delay. We all know that the actual data resides in data nodes. Okay, now here the actual data is present in block A, B, C, D. Now, let's say block A, B, C, D are arranged in data node 1, 2, 3, 4 respectively. Now, you can ask me a question. Hey Madhu, Hadoop has arranged block A, B, C, D in data node 1, 2, 3, 4 respectively. That is well and good. But what if data node 1 fails? Yeah, code chaser, to answer your question, that is, if data node 1 is failed, that means the data which is present in data node 1, that is the block A corresponding data is lost. Our precious data is lost. So, to overcome this, Hadoop has one beautiful solution. To overcome this problem, Hadoop has a kind of powerful weapon. That weapon is replication. As per replication concept, each and every block of data will have their own replicas present in different data nodes. Here, replicas means you can treat it as a duplicate copy of the blocks, duplicate copy of the data. If data node 1 is failed, the data present in block A is lost. As per the replication concept, block A will be having its own replicas in other data nodes. Let us assume block A has its own replica in data node 2 and also present in data node 4. Whenever the block A which is present in data node 1 is lost, one of these two replicas which are present in data node 2 and data node 4 will come into action and will allow the process to run smoothly without the loss of any data. Isn't this concept of replication is very interesting and very useful? On this note, Hadoop deserves an appreciation. Coming back to our topic, Hadoop has a replication factor of 3. That means there will be in total 3 replicas for each block present in the data nodes. We can customize the replication factor in HDFS site.xml. If we see HDFS site.xml, we can see it here, dfs.replication, and here the default value is 3, which will indicate the number of replicas. So we can increase the number of replicas or decrease the number of replicas by configuring it here. One point here, code chasers, we have 3 replicas for each block. That is very fine. But arranging those blocks in all data nodes in such a way that in future, if any of the data node fails, the other active data node should contain the blocks which were present in the damaged data nodes. To throw some light on that point, if the data node 1 is damaged, then the data present in the blocks A, D, B is lost. So the replicas which are present in other nodes come into rescue. That means the replica of block A and B which are present in data node 2 and the replica of B which is present in data node 3 will come into rescue operation and will allow the process to run smoothly without the loss of any data. Wow, Madhu, this is really fantastic. But one small question again. Hey, it's okay, code chaser. What is that? We have 2 replicas of block A, right? One in data node 2 and one in data node 4. But why is the replica present in data node 2 is picked over the replica present in data node 4? Is there any strategy followed here? Could you please throw some light on this point? Of course, code chaser. If there is any data node fails, the blocks present in that damaged data node will be lost, right? Hadoop will search for the nearest replicas of the blocks present in active data nodes. To be more clear on this point, the damaged data node is data node 1 and block A is one among the blocks in data node 1. The replicas of block A are present in data node 2 and data node 4. But Hadoop will search for the replica of block A which is very near to data node 1. Now here the replica of block A which is present in data node 2 is very much near to data node 1 compared to the replica present in data node 4. So Hadoop chooses the replica of block A from data node 2 over the replica present in data node 4. Hey code chaser, I hope I have cleared your doubt. Yes, Madhu, the doubt is well cleared. Thank you so much. Hey code chasers, I hope you understood the concept of blocks and replication in HDFS, that is Hadoop Distributed File System. The next video will be on rack awareness in Hadoop Distributed File System. Trust me, next video gonna be very much more interesting than this video. So stay tuned to our channel. Quick information, Pyspark with Hadoop. end-to-end development course is running in our channel. If you are interested, please check it out. If you like my work, do support me by liking our videos and subscribing to our channel. Also, don't forget to share the videos to your friends if you feel the content is worth. Also, one thing, click on the bell icon to get notified for such useful content.